Hello, this is a tutorial on how to create a shear force diagram from a simply supported beam, fully solved, to work out reaction forces and positive pin forces. So this is my beam. I have a 3 single loaded points at 125 kilonewtons, 100 kilonewtons and 160 kilonewtons. What I have reaction forces which we can call RA, which is 155, and RB, which is 230. If you don't know how to solve this, I did an earlier walkthrough on how to solve these, which you can sit and watch prior to this video. So what we need to do is we need to work out what is our shear force on our beam and work out, is our beam in positive shear or is it in negative shear. So essentially, how is the torsion and how is the slice going to happen on our beam. So to do this, what we have to do is we have to basically build up a little line graph. So I'm just going to build a graph kind of template, X and Y. So we're going to do some black. Like so. And this side of my line will be my loads, and down the bottom my X will be my distance. So my X and Y, what I probably should have done is get it properly lined up, but that's okay. So what we're going to have here is 0 meters. I'm going to have 2 meters, 4 meters, 6 meters, and then on the end I have 7 meters here. So I'm going to try and follow the actual lines. So what essentially we're going to do is we're going to now pinpoint parts of our shear. So if we use the formula let x equals 0 meters, we can now pinpoint everything on this beam. Okay, we have what's then sort of going on. So before we start, what we'll have to get into a habit of is working out what's our up and down values, which is positive, which is negative. Now, in forms of mechanics, anything coming up is positive, anything pushing down is negative. So these symbols would all become negative, the point loads, and my reactions would then become positives. So if I'm going to let x equal 0, okay, at my 0 meters, I've got positive 155 kilonewtons of shear force. So I'm going to come up and I'm going to choose a point here, and I'm going to put this point of 155. I'm just going to put in here up top times 10 to the 3, so I'm going to keep putting 155 kilonewtons. Now, as I look from 0, which is obviously here, nothing happens on my beam until I hit the 2 meter mark. So what now I'm going to do is I'm going to draw all the way to my 2 meter mark, which is here. Now I'm going to repeat the same thing. If I now let x equals 2 meters, okay, we're going to work out what's going on now. At 2 meters, obviously we go down minus 125. So 155, okay, that's going to send me near enough all the way down to about 30. Well, not about, it is 30. So put that as 30 there. And again, looking at it now, between 2 and 4, nothing happens until we hit then the 4 mark. So I'm going to keep that then duration all the way to 4. Then I'm going to do the same again, let x now equal 4 meters. Okay, at 4 meters we're going to have 100 kilonewtons, that's going to take me down to minus 70. So I've probably really drawn that distance really in the wrong place. Put something like here. minus 70, and again at minus 70. Nothing happens until we hit the 6 meter mark. At the 6 meter mark, okay, we're going to let x now equals 6. We know we're going down to 160 kilonewtons. That's going to take us down all the way down to minus 230. Like so. And again, nothing then happens until we hit the end of our beam, which is where 230 is then a positive. So we're going to let that carry all the way through to 7. And then we're going to come all the way back up then to 0. So there's my little graph. What I'm going to try and do is very neatly use a green, let's use a green, use my ruler. Because I'm using a touch screen, this is fairly straightforward. What I do is I do all the, I'm a bit lazy. Save, keep spinning it round and round. Do your horizontals first and then your negatives. Obviously just roughly at this stage. Now you can actually, if you want to, mark it from 0, because this goes from 0 up. So there we have it. So when we zoom out, there we have it. There is our shear force diagram. We obviously have a positive zone, which is this side. Okay, you can mark as a positive shear, and obviously this side is my negative shear. We know that there's a neutral zone which transitions, which is where it crosses 0 at the 4 meter mark, which is where we can say our beam goes from positive to negative shear. And that's how we produce our shear force diagram using the example above.